Welcome to ScienceCover.com. Let's try the Do Now task. Pause the video and find the 10 types of energy that are hidden in the word grid. Today we will look at work done. What is work done? How to calculate the work done using an equation, and how to use that equation in the horizontal and vertical. First, let's look at what is meant by work done. Work done is what we call the amount of energy that gets changed from one form into another by a component. In order for this kettle to heat water, we must change electrical energy into thermal energy. The amount of energy it converts is the work done. To move an object, a force must be applied. This uses energy. The amount of energy used is called the work done. The work done depends on the size of the force and the distance that the object is travelling. We can calculate the work done using the equation work done equals the force multiplied by the distance. The units for work done should be joules, as it's a type of energy, and the force should be in newtons. Distances are measured in meters. Now pause the video and complete task 1 and task 2. Let's check our answers to task 1 and task 2. Task 1. What is the work done? For an object to move from one position to another, a force must be applied. The force will transfer energy to the object. We call this energy the work done. Work done by a force depends on the size of the force and the distance that the object travels. 1 joule of work is done when an object is moved 1 meter by a force of 1 newton. So the missing words in order were force, energy, work done, size, distance, and meter. Task 2. The unit for work done is joule. We can calculate work done by force multiplied by distance. The unit for force is newtons, and the unit for distance is meters. Let's look at an example of how to use the equation. Example 1. A Scotsman tosses a caber at the Highland Games with a force of 200 newtons. The caber travels 9 meters. How much work has been done on the caber? Work done equals the force multiplied by the distance. First, write this equation. Then, substitute in the numbers we have been given for the words. So the force is 200 and the distance is 9. Work done equals 200 times 9. This equals 1,800. The unit for work is joules, so we must represent this with a J. Let's look at another example. A girl kicks a football with a force of 50 newtons. The ball travels horizontally for 15 meters. How much work has been done on the ball? Work done equals the force multiplied by the distance. First, write the equation. Then, substitute the numbers we have been given for the words. So, it's 50 newtons as a force and 15 meters as a distance. Work done equals 50 times 15, which is 750. The unit for work done is joules, so we can represent this with a J. Now pause the video and attempt task 3. Let's look at the answer to task 3. A box is moved 3 meters by a force of 2 newtons. Calculate the work done. Work done is the force multiplied by the distance. This is 3 meters times by 2 newtons, which equals 6 joules. Number 2. How much work is done by a car engine to move the car 1,000 meters if the force of thrust produced by the engine is 30 meters? Work done is the force times the distance. 30 newtons is the force, times by 1,000 meters is the distance, giving us a work done of 30,000 joules. A helium-filled balloon is floated into the air. The wind supplies 3 Newton horizontal force to the balloon and blows it 2 kilometers. How much work is done by the wind on the balloon? Well, 2 kilometers is 2,000 meters, so we need to use 2,000 as the distance. Work is the force times the distance. The force is 3 newtons times by 2,000 meters, which equals 6,000 joules. The equation can be rearranged to find the work done, force, or distance. To help us use the equation correctly, let's use an equation triangle. The equation triangle should have the work on the top of the triangle and the force and distance at the bottom. If we cover up what we want to find, the remaining parts of the triangle will tell us how to set the equation out. If I want to know the work done, cover up the work done. This leaves me force multiplied by distance. So work done is force multiplied by distance. If I want to find the force, I can cover up the force, which leaves me work done at the top of the triangle and distance at the bottom of the triangle. So force is equal to work done divided by the distance. If you want to find the distance, then cover up the distance. And this leaves us work done on the top of the triangle and force on the bottom of the triangle. So distance is the work done divided by the force. Let's look at how we can use this triangle in a real question. A classic car uses 2,000 joules of chemical energy from the engine and travels for 400 meters. What force did the engine produce? We have been asked to find the force, so cover up the force on the equation triangle. This leaves work at the top divided by distance on the bottom. So work divided by distance will give us the force. Write out the equation. Next, substitute the numbers we have been given. So work done is 2,000 joules and distance was 400 meters. So force must equal 2,000 divided by 400. This equals 5. The unit for force is newtons. So we should write 5 capital N. Let's look at another example. A girl throws a javelin with a force of 15 newtons. If she transfers 600 joules of chemical energy to the javelin, how far will it travel? We've been asked to find the distance, so cover the distance on the equation triangle. This leaves work at the top divided by force at the bottom. So therefore, distance is work divided by force. Write out the equation. Next, substitute in the numbers we have been given. The work done is 600 joules and the force is 15 newtons. Distance is 600 divided by 15. This gives us 40. And the unit for distance is meters. Now pause the video and complete task 4. Let's check the answers to task 4. Work done is 1400 joules. The distance should be 20 meters. The next distance was 5 meters. The force you had to calculate was 30 newtons. The force was 5 newtons. The distance was 600,000 meters. And the force was 2000 newtons. We can also use work done in the vertical plane, using the height something travelled upwards to calculate the energy gain. If an object is lifted at a constant speed, then the energy gain will correspond to the amount of gravitational potential energy gained. Let's look at an example. A rocket is fired upward with a resultant force of 40 newtons and travels upwards at 30 meters. Calculate the work done by the rocket. This situation is almost identical to the earlier examples, except we are working in a vertical plane. Work done equals the force times by the distance. Write the equation. Then substitute in the numbers we've been given. The force is 40 newtons and the distance is 30 meters. So work done equals 40 times 30. This equals 1200. And as work done is energy, the units are joules. Let's have a look at another example. A lady climbs a flight of stairs at a constant speed. She gains 3000 joules of potential energy and her weight is 60 newtons. How high are the stairs? This example is slightly different. We've been given potential energy and asked to calculate the height. Potential energy gained in a situation is equal to the work done. So rather than say force times distance, we can use her weight as the force and the height of the stairs as the distance. Now substitute in the values we've been given. We were told that the work done is 3000 joules. And we were told that the weight was 60 newtons. So now we have 3000 equals 60 times the height. To get the height, we must rearrange the equation. So 3000 divided by 60 equals the height. 3000 divided by 60 equals 50. And since the height is a distance, the units are meters. So the height is 50 meters. Now pause the video and complete task 5. Let's check our answers to task 5. The squirrel moves an acorn from the ground and raises it 10 meters to the top of a tree. If the weight of the nut is 2 newtons, how much energy is used to raise the nut? Work done is force times distance. Weight is a force, so that's 2 newtons, times by 10 meters distance. That equals 20 joules of energy. Question 2. A hot air balloon weighs 120 newtons. If the balloon rises 50 meters into the air, how much work has been done? The weight of the balloon is 120 newtons, that's a force, times by 50 meters, the distance, and that gives us 6,000 newtons. Question 3. A man drops a coin from the top of the Empire State Building. If the coin has a weight of 0.1 newtons and falls a distance of 381 meters, calculate the work done. So work is force times distance. The force is 0.1, times it by 381, and we get 38.1 joules of energy. Question 4. A car with a weight of 30 newtons is lifted vertically by a crane. If the crane uses 180 joules of energy in lifting the car, how far has the car been lifted? Work done equals force times distance, but we want the distance, so we can rearrange that so that distance is work divided by force. That's 180 divided by 30, which equals 6 meters.